The movie we chose to analyze was Home Alone 2. We chose to analyze two different scenarios in which the character, Marv, was falling from two different buildings with different heights. Our question was, are the falls in Home Alone 2 accurately represented?
In the first scenario, we timed how long it took Marv to fall from a certain height, which was 2.5 seconds. We then used the formula d equals VIT plus 1/2 AT squared to figure out the distance. We know that the initial velocity is 0 because he is not moving. As a result, the equation is reduced to distance is equal to 1/2 AT squared.
As every object falls on Earth, its acceleration is 9.8 meters per second squared down. Then, using the same equation as we did before, of d equals 1/2 AT squared, we multiplied 1/2 times 9.8 times 2.5 squared, which equals 30.625. Knowing that distance of 30.625, we then use the equation Vf squared equals Vi squared plus 2AD. Since the Vi is 0, the equation is simplified to V equals 2AD. Then we multiplied 2 times the acceleration of 9.8 times the distance of 30.625. This gives us a final velocity squared of 600.25 meters per second. We then took the square root of this, which is 24.5 meters per second.
In the other scenario, Marv fell again from a building that was higher than the building in the last scenario that we analyzed. We again timed how long it took for him to fall, which was 6.3 seconds. Then we used the formula d equals VIT plus 1/2 AT squared. Similarly to the last scenario, we know that the initial velocity is 0 because he is not moving. As a result, the equation is d equals 1/2 AT squared. Again, the acceleration of a falling object on Earth is 9.8 meters per second squared.
Then we multiplied 1/2 times 9.8 times 6.3 squared, which equals 194 meters, which is the distance. Then, knowing that distance, we then used the equation final velocity squared is equal to the initial velocity plus 2AD. Again, since the VI is 0, the equation is V equals 2AD. Then we multiply 2 times the acceleration of 9.8 times the distance of 194. This gives us a final velocity squared of 3,802.4 meters per second. We took the square root of that, which is 61.66 meters per second.
We then set up a proportion, big distance divided by small distance equals big velocity divided by small velocity. These two should have the same scale factor. The proportion simplifies to 194 divided by 30.625 equals 61.66 divided by 24.5. This simplifies to 6.33 equals 2.52, which isn't the same scale factor. Thus, we came to the conclusion that the falls in Home Alone 2 are not accurately represented.
In another scene, a brick falls into Marv's head from about 10 meters away, and then Marv gets right back up. We will evaluate the force of impact to see if he really could have gotten right back up, or whether he would have been hurt. A standard brick weighs about 3 kilograms. We assume a 1 centimeter deceleration distance. Distance it took the brick to stop once it hit the robber's head. We used a few different formulas to determine the force of impact. First, we determined the velocity upon impact by using the formula final velocity squared is equal to the initial velocity squared plus 2AD. Using 9.8 for the acceleration, 10 meters for the distance, and with an initial velocity of 0 meters per second, we get the velocity squared on impact of 0 plus 2 times 9.8 times 10, which equals 196, and 14 meters per second is the square root of that.
Next, we determined the rate of deceleration to see how fast the brick is decelerating upon impact, using the formula A equals V squared divided by 2D, with D being the deceleration distance of 1 centimeter, which is 0.01 meters, and V squared being 196 meters per second, as we just calculated. The rate of deceleration is 196 divided by 0.02, which equals 9,800 meters per second squared. The force of the impact can be determined by using the formula F equals ma, with A being the rate of deceleration. The mass of the object is 3 kilograms, and the rate of deceleration is 9,800 meters per second squared. So the force is 9,800 times 3, which equals 29,400 newtons. So we think that Marv would not be able to get back up after being hit in the head with a force of nearly 30,000 newtons.
Thanks for watching.